All right, happy Friday, guys, or Thursday, sorry, not Friday. Hopefully you got the um, paper homework done, because after today we're going to do a Hawks assignment. And so if you need help, make sure you're reaching out and letting me know. The Hawks is going to be 1.3. It is a very long one, but should know how to do everything after today. So we're going to do factoring part two. Last class we talked about factoring on GCF, factoring trinomials of the form x squared plus bx plus c, factor by grouping, and factor with special patterns. So now some more special cases. We're going to talk about special cases of cubes. The SOAP acronym does help with this. It's same, opposite, always positive. So what that means is the same sign, okay, is going to go first. Minus. And it's going to be the opposite sign, second, and always positive at the end. Okay, so example, this right here. If you get something x cubed plus 27, aka two terms, they're probably perfect cubes. So if I did the cubed root of 27 and I broke it down, perfect cube is 3 and the cubed root of x cubed is x. So what you do is you do same sign, and it's going to be x squared, okay? And then I'm going to do the opposite sign, so it's going to be a minus, and this is where I just do 3x. I do the 3 that I have from the perfect cube, and then I attach an x to it, and the last one's always positive, and I square my number that I got. So that's how you factor a perfect cube. Same way here, if you see something that's two terms and it's got x cubed, probably going to be a perfect cube. The cubed root of 64 is 4. Cubed root of 125 is 5. So we start off with the same sign, 4x minus 5. We square the first term, which would be 16x squared. So 4x times 4x. Okay. We take 5 times 4 and use the opposite sign. Sorry, 4x to get 20x. And the last one's always positive, so I say plus 25. And that's how you factor special trinomials. Or perfect cubes, I mean, is what we're kind of talking about. So sum of cubes, difference of cubes, that's how you'd factor those. You won't see very many of them, but there are a couple on the Hawks, so just keep that in mind. Now, the big thing today is factoring trinomials using the AC method. We call it the AC method because you take the A times the C. We use AC because last time it was always a 1 in front of the x squared. Well, now that's going to be a number. So here's what you have to do. You take 2 times negative 15 to get negative 30. Now let's list the factors of negative 30. I'm looking for it to add up to that middle number right here. So I want the bigger number to be positive. So if I do negative 130, negative 215, negative 310, negative 5 and 6. Well, this right here adds up to that positive 1 that I'm after. So now I'm going to rewrite this trinomial as 2x squared. We're rewriting the middle part because if I combine those, I would get a positive 1x. So now what we're going to do is I have 4 terms. Anytime you see 4 terms, you should immediately think factor by grouping. So if I group the first two, the only thing they have in common is x, but I get 2x minus 5. If I group the second two, they have a 3. I get 2x minus 5. Notice this is the same. So this factors into x plus 3, 2x minus 5. That's how you factor a trinomial using the AC method. And again, you use that when the number in front of the x squared is not 1. So same thing here, I take 6 times negative 6 to get negative 36. It's a negative number in the middle now, so the bigger one's going to be negative whenever I'm listing the factors. But you look at that right there. 4 negative 9 adds up to that negative 5 I'm after, so let's rewrite it. And then factor by grouping. When we do that, we get our answer. 2x minus 3 times 3x plus 2. All right, so that's the AC method. Go ahead and try it on D. So I expect you to pause the video and C. However, these are a little bit harder just because you have to rewrite it first, and that's what I would do. I'd always put my x squared first. But notice this is a negative one, so I'm doing -8. That adds up to that -2 in the middle. So if I rewrite it, and I factor by grouping, this one they have a -x in common, so I get x minus 2. This one they have a -4 in common, so I get x minus 2. So then it's -x minus 4, x minus 2. Next one. Yeah, they're throwing x's and y's in there, but it's not any different. I still take 2 times 3 to get 6. If I do -1 and -6, because that's got a negative here, that's going to add to that -7. So I would do 2x squared, minus xy minus 6xy plus 3y squared. And we're still going to do grouping. When you do that, first one's just an x. Second one's a -3y. Notice they have the same thing inside parentheses, so then I would combine it to factor into x minus 3y and 2x minus y. So now, putting it all together, factoring strategy, what you do first is you always factor the GCF if possible. Now, you're going to look at the two terms after that. If there are two terms, can we use a special pattern? Most of the time you can. If there are three terms, can I use a special pattern? Most of the time you can. If there are three terms and it's not one of the special patterns though, try factoring by using the guess and check method or what we did earlier whenever we listed the factors. All right, if there are four terms, try factor by grouping. If you can't do any of that, then we're going to go back to the AC method and go from there. So this first one, okay, I just have four problems that kind of throw everything at you. What you're going to do, I'm going to do my GCF first. So my GCF is -3x, so I get x squared minus 9. That right there is a perfect, or a sum of perfect squares. Difference of squares. So it factors into -3x, x minus 3, x plus 3. You always have to make sure and check, can you factor it further? Because most of these you can. That's why I threw these examples in here. So this one I have four terms, so the first step is to factor by grouping. So I get a squared, a plus 1, you get -4, a plus 1. So then you have a squared minus 4, a plus 1. Again, how I can factor further, this is the difference of squares. So that factors into a minus 2, a plus 2. I still have my a plus 1 at the end. Kind of moving down. Three terms. I still want to do GCF. They all have 2x that I can factor out. So I get x squared plus 4x plus 4. Now let's factor this. There's three terms. I'll list the factors of 4, 1 and 4, 2 and 2. That adds up to that middle number. So I would get x plus 2, x plus 2 is what that inside parentheses is going to factor into. Last one, factor out a y. I have y to the fourth minus 81. Again, a difference of squares. So this becomes y squared minus 9, y squared plus 9. This one's kind of unique because it's got another step. Because the y squared minus 9 can be factored into y plus 3, y minus 3. And it ends up being that. You have to make sure you're looking for all the patterns that you see. The reason why we're doing so many examples is because the more you see it, the easier it gets. All right? So again, if you have any more questions, just let me know. The assignment is 1.3 HOCs. Otherwise, have a good weekend, guys.